Okay, so last week, we mainly learned about uh, permutation. Permutation is when the order matters. Like you put uh, like the book on your bookshelf, then uh, depends on which book go first, which go second. Those are different. Even though you might have the same, say, three books you put on a shelf, you may have just A, B, C. You just have those three books, but you could have like A, B, C lined up, or A, C, B, or you could have B, A, C, or B, C, A, or C, A, B, and C, B, A. So you have six different ways to arrange it. So this is called permutation. And now to uh, study permutation, there are two kinds of permutation. One is called with replacement or with repetition. With replacement. Okay, the other one is called without placement. Replacement. Now, for example, on this one, this is called without replacement, because once you pick the one book, you only have two more books to choose from. Once you pick two, you only have one more book to choose from. Okay, and with replacement, it means when you pick it up, you have to put back. So, for example, if you have three books, now if we are doing this with replacement, that means once you pick the book, you put them back, say put them back in a bag. So still three books. So then we could have end up with something like AAA, and that is possible if we put the book back. So that's called replacement. Okay, are we good down here? All right, thank you, Grayson. Thank you, Mia. Thank you, Mason. Thank you, Roger. Okay, now let's looking at there's something we learned last week, big name, but actually is pretty simple. Concept is called the fundamental counting technique. See, that's kind of big words, or counting principle. So big word, but it's actually pretty simple. Is that, like, say, if you have um, something to choose from, like say for we'll say we have the choice. Like say we're going to order uh, uh, a meal. So now we got the choice of say entree, and we have choice of drink. We have choice of say dessert. Now let's see, we got three entrees to choose from, five different drinks, and also four different dessert. Now, how many different combination we have? Well, we can see that entree we have three, so there's three. The drink has five. Then dessert have four choices. So the total number of different meals we can make is 3 times 5 times 4. So that gave us 60. So that's basically what the fundamental counting principle means. We just find how many choices on the first one, how many choices for second one, how many choices for third one. We just time them, multiply them together, and we got the total numbers of different choices. Okay, are we good on this one? Yeah, okay. I'm going to show you another example. Is still this permutation with or without replacement. So for example, if we want to make a two-digit number, and out of some choices, like out of the 1, 3, 5, 7. Now, if we are doing permutation without replacement, that means for the first digit, we have 4 choices. So that's 4. For the second digit, we already used 1 out of those. So we only have 3 left. So therefore, we got 4 times 3. Now, this is called without replacement. So once we used it, we cannot reuse it again. Now, if we do with replacement, is we pick something out and we put back. So that means the first time we have 4 choices. On the second digit, we'll still have 4. So now this is 12. Now we got 4 times 4, we got 16. So this is with replacement. Good. Thank you, Mia. Thank you, Mason. Roderick and Grayson, are you guys good? All right. Grayson, are you good? Okay. All right. So now, permutation without replacement, we actually have a formula. We talked about last time. We write it as P. P stands for permutation. N is total number of things we can choose from. And R is how many out of the N we can choose. So for example, this formula is writing as N factorial, then N minus R factorial. So last time we're talking about if we put two-digit number out of 1, 3, 5, 7. So in this case now, our N is 4, our R, because we picked 2 out of the 4, is 2. So therefore, what we got here is 4 P2, that equals to 4 factorial, and 4 minus 2 factorial. That gave us 4 factorial over 2 factorial. And we know 4 factorial just 4 times 3 times 2 factorial. And we got 2 factorial on the bottom, that cancel, we got 12. So now with the formula, we can easily find out how many possible arrangement. For example, let's do some example here. We need to pick 3 books out of 5. Now, how many choices we got? We have to line up. So because if we put this on the shelf, then the order matters. And we only have 5 books. Once we put the one onto the shelf, then we'll not put it back. So this is a permutation without replacement. So we can use the formula is 5, 3. So we got 5 factorial and 5 minus 3 factorial. And that gives us 5 factorial and 2 factorial. So 5 is 5 times 4 times 3 times 2 factorial. Then we got 2 factorial. That cancel. We got 4 times 5, 20 times 3, 60. So that's how the formula goes. And without the formula, you can also see why is that case. For the first one, we got 5 choices. Once we figure out, put down the first book, we need 4 choices left. Then we have 3 left. So therefore, it's 5 times 4 times 3. That's exactly the same number. But with formula, then we can do that much faster. Okay. All right, are we good on this one? Okay, now I'm going to give a couple work for you to do. Uh, so let's see. Uh, we have, let's say we got 4 people, and out of that, we are going to line up 3 people. 3 line up. So 3 out of 4 and line up. And how many different arrangement can we get? Since we line them up, then order matters. So this is a permutation way without replacement. Okay. Good job, Mason. Good job, Mia. Yeah. Rodri and Grayson, what's your answer? All right. So let's use if we can do this in 2 ways. One way is using the formula. We got 4 and 3. Our n is equal to 4. Our r is 3. So using the formula, we got 4 factorial and 4 minus 3 factorial. And it's got 1 factorial. Now 1 factorial is just equal to 1. And 4 factorial, we know that is 4 times 3 times 2 times 1. So we got 4 times 3, 12, times 2, 24. So it's one way we can do that. Another way is that we just we can draw them out. Out of the 4 people, our first choice, we got 4 to choose from. And for the second line up, then we only have 3 left. Third, we got 2 left. So it's 4 times 3 times 2. That's 24. Good. Okay. All right. Rodri, we good? Okay. All right. Let's looking at another choice. Um, we got suppose you got 7 books and you want to pick 5 and put them on your shelf. on a shelf. So how many different arrangement can you get? Good job, Mason. Good job, Grayson. Yeah. Mia, you can work it out. You can use calculator and see what is the number. Okay. So now if we use the formula, we see that this is 7, this is 5. We got 7 factorial, 7 minus 5 factorial. We got 7 factorial over 2 factorial, which is 7 times 6 times 5 times 4 times 3, then times 2 factorial. We got 2 factorial, that cancel. So we got 2,520. And again, if you want to try, you can see that you got 5 on the shelf. The first one is 6. They have, once this book is picked, when you have 6 left, then once those two picked up, when the 5 left, then 4 and 3, exactly like what they're here. And we'll get that. Okay. Are we good on this one? Okay. Let's try one more, okay? Let's see, we got uh uh all the even numbers. Actually, let's looking at the just odd numbers. 1, 3, 5, 7, 9. We got 5. So out of that, we're going to make a 3-digit number. And this time we are doing without replacement. That means once you use that, you cannot reuse again. Just imagine that you pick a number from a bag. I mean, there's 5 numbers in a bag. You pick out a number, you put it down. Then you pick another number, you put it down. You put another number, you put it down. Now, so how many different arrangement? So this is called without replacement. Good job, Mason. Raji? Yeah, what's your answer on that? Yeah, if you get wrong, think how can you get that, figure out the right answer. So we got five to choose from, and we make them into a three-digit number. All right, so let's look at how we do this. Remember the formula. The formula is this. We got n and n minus r. So in this case, uh we got five, and we picked 3 out of 5. So that equals to 5 factorial over 5 minus 3 factorial. That's 5 factorial over 2 factorial. And that just simply 5 times 4 times 3 times 2 factorial divided by 2 factorial. That cancel. We got 5 times 4, 20, 20 times 3, 60. So we got 6 different digits. Okay, so now we have, or you can say the first choice, we got 5. After that, we have 4 left. After that, we got 3 left. So our choice is 5 times 4 times 3, we got 60. Okay. Are we good on this? Thank you, Grayson. Thank you, Mason. Thank you, Mia. Thank you, Roger. Okay, now let's kind of make that more interesting. Is out of the 60 different, all the possible arrangement, how many of those are divisible by 5? So think about that. Out of this 60, how many uh how many numbers that are divisible by 5? Good job, Mason. Yeah, if you don't know how to work this one, you can type just IDK, but definitely give it a try. So what that means, a number that is divisible by 5. Grayson and Mia. Yeah, if you don't know how to do that one, you can just type IDK. Okay. Mia. Yeah. Mia, are you there? Okay. All right. So let's look at. Well, definitely it won't be 60. We know that uh, out of five digit, make a 3-digit out of that, we have a total of 60. We need to figure out how many of those are divisible by 5. Well, how do we do that? Well, if it's divisible by 5, what happens to the last digit, which is units digit? The unit digit has to be a 5, so that's fixed. That we just have one choice. That's fixed. Now, once we pick the 5 here, for the first digit, the 5 is gone. We only have 4 to choose from, so this will be 4. And of course, second digit will be 3. So altogether is 4 times 3 times 1. That gave us 12. So 12 out of 60, we only got 12 that is divisible by 5. Okay, are we good here? Thank you, Mason. Thank you, Mia. Thank you, Grayson. Roger? All right. So now we're going to move on to something called combination. Combination means the order does not matter. Well, what are the scenarios? For example, if each one pick 3 books out of 5, and you just want pick 3 books to read, maybe on your vacation or camping trip. So in that case, it really doesn't matter. You just pick 3 books. The order does not matter. And so then the number of outcomes are different. And well, actually, let's go back a little bit simpler. So let's say if we want to pick 2 books out of 3, then we look at 3 books out of 5, 2 books out of 3. Okay, and let's say it's A, B, C. Now, if we put them on the shelf, that is the order matters. So we can have AB, AC, and BC. Those are just 3. Or we can see that our first choice is 3. Oh, sorry. Yeah. AB, AC, BC. We also have BA and CA and CB. So 3 times 2, right? First, we got 3 choices. Second, we got 2. Then we got 6. But if we're looking at, this is called a permutation, which means, again, order matters. Then combination, the order does not matter. For example, you just pick 2 out of 5. How many choices can I have? Since order doesn't matter, A, B, and BA means the same thing. You just got 2 books, same 2 books. So in this case now, our choice actually became either AB or AC or BC. So we don't have 3. Okay. Yeah, are we good here? See the difference between permutation and combination? Okay, thank you, Mason. Thank you, Mia. Thank you, Raji. Grayson, are you good? Okay, so now we're going to looking at 3 out of 5. Now, 3 out of 5, if it's permutation, we know we have say A, B, C, D, E. So we have the first choice, 3 out of 5. We got 5, 4, 3. So 5 times 4 times 3, that's 60. Now, if we only do combinations, permutation, and so how many we can have? Well, if you do the combination, we have A, B, C, that is 1. And we just find something different. A, B, C, A, B, D, and A, B, Z. See, different books. And then have different books. Then we could have A, C, D, or A, C, Z. And then we're going to looking at just B, B, C, D, and B, C, Z. Then we got B, C, D, B, yeah, B, C, D. Then we got B, C, Z. Then we have B, D, Z. Then we look at C. C only have C, D, B, Z now, and that's it. Got 1, 2, 3, 4, 5, 6, 7, 8, 9. Because all those are different threes out of that. 1, 2, 3. Then 1, 2, and oh, did I missing one? Let's see. A, B, C, A, B, C, A, B, D, A, B, Z, A, C, D, A, C, Z, and oh, there is A, D, Z. I missed that one. A, D, Z. That's different. And once we chose that, we got B, C, D, B, C, Z, then B, D, Z. We got that. Okay. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, let's see. So we know it's getting a lot smaller. But what's the formula here? The formula actually for the combination is a little bit from permutation. Permutation we write as this. That is n factorial and n minus r factorial. So that's permutation. The combination we write as C and R, and holding it as n factorial and n minus r factorial and r factorial. Okay. All right. Now in this case, the first one is P 5, 3. Then we know 5 factorial, 2 factorial, and we know we got 60. But on the second one, this one is C 5R. We have 5 factorial, 2 factorial, but also we got this one. That's 3 factorial. So all we got here is 5 factorial times 4. Then we got 3 factorial here. And the bottom is 2 factorial, 3 factorial, that cancel. And 5 divided by 2, sorry, 4 divided by 2 is 2. So we got 10. And okay. Yep. Are we good on this one? Okay, let's have some examples if we can see the difference. We're going to do basically side by side permutation versus combination. Okay. Let's see. We're going to pick 4 out of 5 to make a team. Now, one for the permutation order matters. So let's see. For example, they had to be on 4 different positions. Okay, so someone has on here, someone here, someone here, someone here, just in case they are kind of spread in a different way. So in that case, the order matters. So we got P, 5, and 4. So we got 5 factorial, 4 minus 5 minus 4 factorial. There's just 1 factorial. So top is 5 times 4 times 3 times 2. Then we got this is 20. This is 6, so 120. Now, if the order does not matter, we just need to pick 4 out of 5. And then that was the combination. So 5 and 4. And that gave us 5 factorial and 5 minus 4. That's the same. But we have this 4 factorial. Then the 5 factorial is 5 times 4 factorial. And this is just 4 factorial. And we only get 5. You can see quite different. If we do permutation order matters, we have 120 different way of putting those 4. But the order doesn't matter. We just pick 4 out of 5. Then we just get 5 different way of doing that, which makes sense. You can think of get 5. Instead of think about pick up 4, you think about get rid of 1. Well, that's only 5 different person can get rid of 1 at a time. Okay. Yeah. Are we good on this one? Thank you, Mason. Thank you, Nia. Raji. Thank you, Grayson. Okay. Now I'll give you a problem to work on. So now think about you pick 3 books out of 6 for camping trip. So in this case, the order does not matter. Okay, see what you got. Yeah. Okay, we're going to use a different formula because this is a combination. We know the permutation formula is this. It's n factorial, n minus r factorial. Then the combination formula is this. N factorial and n minus r factorial. We got r factorial.
What does N and R stand for?
What's that?
What does N and R stand for?
R, it's just like how many you pick out. So in this case, our R will be 3. And our N will be 6. Okay. Yeah, so pick R out of N. You can think of that. The general thing is pick R out of N. Okay, if you don't know how to do this one, you can type IDK. Okay. Good job, Mason. Yeah. Mia, what's your answer? Yeah. Mia, what's your answer? All right. See how we basically just plug in this equation here. This is for combination. The reason it's combination is because it doesn't matter the order of the book. So we just plug that in. We got C, N is 6, R is 3. Then what we got here is 6 factorial and 6 minus 3 factorial and also 3 factorial. So we got now 6 factorial is 6 times 5 times 4 times 3 factorial. So that way we can cancel 3 factorial. And 6 minus 3 is also 3. But this got canceled. Now 6 factorial is 3 times 2, which is 6. So this is 6. And 6 and 6 cancel. We got 20. Okay, are we good on this one? All right. Yeah. Uh, Roger, you good? Okay. So let's try different ways, okay? Um, we're going to do, let me actually keep the formula. And then we're going to say, uh, if you got, if you're trying to pick two person out of, say, out of 7 students, you pick 2 to represent your class. How many different arrangement can you make? So it's 2 out of 7. Okay. Good job, Mason. Hello. Yeah. Rodri and Mia, what's your answer? Okay. Uh, Mia. Okay. Uh, yeah. Mia, are you there? All right. Okay. So just like you did this before, the only difference now is we have this term divided by r factorial. So we got 2 out of 7. Okay, our n is 7, our r is 2. So therefore, we got 7 and 2. That equals to 7 factorial and 7 minus 2 factorial and over 2 factorial. So that gives us 7 factorial. This is 5 factorial and 2 factorial. Okay, are we good here? How to use this formula? If you're good, give me thumbs up. Okay, thank you, Mason. Thank you, Rod. Uh, thank you, Mia. Okay, Roger, you good? Okay, so now we can see that 7 that equals to 7 times 6 times 5 factorial. And this is 5 factorial, this is 2 factorial. So we know this got canceled. 2 factorial just 2. So 6 divided by 2 is 3. So 3 times 7 is 21. Okay, are we good on this one? Okay, all right. Okay, now I'll just give you one more, okay? Yeah, we do pretty much the same thing. So now we're going to so let's see, we have a circle and we put 5 points on that. Then we can make triangles. It's 1 triangle, it's 2 triangle. Now, how many triangles can we make? So, which means it's the same as 3 out of 5. So out of 5 points, we need to figure out, pick 3 points, then we can make a triangle. So in that case, how many different triangles can we make? And again, the order does not matter, right? Doesn't matter how you pick those 3. So that's why that's a combination problem. Yeah, make sure the how to use the formula. What is n? N is 5. What is r? R is 3. Now, how do we use that formula to figure it out? Okay, so let's look at this one. How do we do that? Remember, it's the combination. So for the combination, this is C and N is 5, R is 3, and what we got? We got 5 factorial, then 5 minus 3 factorial, and also 3 factorial. So that's 5 times 4 times 3 factorial, and 5 minus 3 is 2 factorial, and 3 factorial. Now 3 factorial, 3 cancel. 2 factorial is just 2 times 1, which is 2. So 4 divided by 2 is 2 times 5. That's where we got 10. Good? Yep. Are we good here? Okay. Thank you, Mia. Thank you, Mason. Roger, are we good? Okay. All right. I'll see you guys next week. Okay. Bye.